Welcome to Study Loop.
So we're told that a person is exposed to fast neutrons on 25 grams of tissue, and that they receive a radiation dose of 300 REM from neutrons with an RBE of 10. The first thing we want to find out is how many rads this person received. So the first thing we know is that the equivalent dose is equal to the RBE of the neutrons times the absorbed dose. So if we want to calculate the absorbed dose in rads, what we can say is that simply solving for this quantity, we find it's equal to the equivalent dose over the RBE of the neutrons, which is also given. So this gives us a value of 300 REM over 10, or equivalently, 30 rad. This is part A. Now in part B, we want to consider how many joules of energy this person received. So the number of joules this person received, or the energy they received, is equal to the weight of the tissue impacted, which is 25 grams, times the absorbed dose, which we decided was 30 rads in part A. This is equal to 0.025 kilograms using SI units. And converting rads to joules per kilogram, we find that this is 0.3 joules per kilogram. And this gives us a total value of 7.5 times 10 to the minus 3 joules. This is how much energy the person absorbed. And now we're asked that if we suppose that the person received the same rad dosage, but from beta rays that have an RBE of 1 rather than 10, how many REM would this person have received? So again, using the fact that the equivalent dose is equal to the RBE times the absorbed dose, if we know the absorbed dose is 30 rads and the RBE is 1, the equivalent dose here in part C will simply be 1 times 30, which just gives us a value of 30. And those units are in REM. And those are our final answers.